Howdy everyone, welcome to our Chapter 12 example problems. This chapter deals with solids, all the various different types of it. Now there's a good bit of this chapter that we'll go over in class, but because of the scope of the course and what the material is, you won't see too many of those problems on homeworks or on the test. So if you're worried about like all the different crystal structures, the unit cells, band gaps for semiconductors, don't worry about it. That's not going to be our focus. Our focus is going to be on the main properties of different materials. So can you tell the difference between metal solids, ionic solids, network covalent solids, that sort of thing? And can you tell the difference between different types of alloys or mixtures? And can you just give some basic definitions for those other things? What is a semiconductor? What is a band gap? All right. So for the problem solving, we're going to focus here on the main things that will show up on the test for problem solving. So number one here, 1217, identifying the type of solid. I love these questions where they give you a series of properties and you use them to identify, well, is it a metal? Is it a ionic solid? Is it a network covalent? Or is it ionic? And so we have to use the properties to either eliminate or push towards a certain property. All right. So it says here, we have a gray substance melts at 700 degrees, conducts electricity, and is insoluble in water. And so for some of these, it points towards something. For some, it just says, no, not that. So first off, the high melting point here. This says, okay, it might be a metal. They tend to have high melting points. It might be ionic. And maybe it's network covalent. Or I can't remember if the book calls them covalent networks. Either way, it's the same thing. It might be. Those tend to even have higher melting points sometimes, but not always. All right. It says it conducts electricity. Now, there is a second one that you have to watch out for. Sometimes it'll say it conducts electricity, and sometimes it'll say it conducts electricity in water when it dissolves. This one's just conducts electricity, and really that one right there is just metals. There are a few solids that other solid types that conduct electricity as a metal. Some very rare, just covalent ones like graphite or graphene. But for the most part, metal is it. So let's just double check to make sure that our last property, that it's insoluble, also matches up with that. And so yeah, if it's insoluble, that would point towards either a metal or a network covalent. And so when we look at these three, we say, okay, the only one that's in common for all three things point towards metal. Ionic compounds don't conduct electricity when they're solid. Ionic compounds tend to be soluble in water, so it's not that. Network covalent, they tend not to conduct electricity either because it's covalent bonding. Only some very, very rare exceptions there. So the most common or most likely choice here, which is what they want you to answer, it's never a guarantee, this is more than likely a metal. All right, but that's how you do that. You just kind of look at each property they give you and say, well, which one could it be? Which one could it not be? See what you have as your most likely answer. All right, for the second type of actual problem where you got to do some work here is identifying alloys. And so we have three types of alloys. We have substitutional, we have interstitial, and we have intermetallic. Substitutional, that's going to happen when the two metals are the same or similar sizes. Interstitial, that means, they're going in between. That is when they're very different sizes. And then intermolecular compound, the important word there is compound. That means it has a set formula. Right? It's whole number formulas. These things are set. So if we look here at this iron and silicon alloy, the fact that it's 0.97 and 0.03, that really doesn't matter too much. It does kind of point towards one, but it's not the deciding factor. The important part is looking, well, where is iron where is silicon on the periodic table. So iron is a transition metal. It's in the 4th row. Silicon's a nonmetal. It's in the 3rd row. There's a whole row of difference there. And silicon's kind of far to the right. There's a decent chance here that silicon is much smaller than iron. Now we could go up and look at it, but based on just using different rows, I'm going to say that that is more than likely an interstitial, because silicon should be a decent bit smaller than iron. I know if it's iron and carbon, it's definitely interstitial. I'll probably go back and check after I make this video just to see the actual numbers. But when you have different rows, probably interstitial. For part B here, we have iron and nickel. Again, the 0.6 and the 0.4, not the deciding factor, though it does kind of point towards substitutional. What we care about is, well, where's iron, where's nickel? 4th row, like we said, this is 3d6, nickel 3d8. They're only 2 boxes apart from each other. They're likely to have incredibly similar atomic radii. Nickel is only going to be a tiny bit smaller, being farther to the right. At least that's our periodic trend. When you get to the transition metals, sometimes there are exceptions. But since they're so close to each other in the same row, they are more than likely going to be very, very similar sizes. So I'm going to say that's going to be a substitutional. Because they're going to have about the same size. The nickel is going to replace where the iron was. Now, when we look at part C, we have a samarium cobalt compound here, and that's the key word. It's a compound. It's not decimals. What you get from there is when you see the decimals, oh, it's an alloy. This is whole numbers. This is 1 samarium for 5 cobalts. That's a set formula. That is all you need to know to say, oh, that is an intermetallic compound. Okay, so that's how you do those. So most other things in this chapter are just definitions. Like I said, do you know what a semiconductor is? Do you know what a band gap is? I'm trying to remember what else was in this chapter. Some of the other forms of carbon they put in at the end for modern materials, nanomaterials. What does that mean? But the key one is, do you know what type of alloy is it, or is it an interstitial? And then can you identify the type of material from a set of properties? That's what I want you to focus on. All right, so that's it for chapter 12. Nice short chapter. I'll see you again in chapter 13. Good luck.